All right, well, hello everybody and welcome. This is an update about the robot hand. What we're seeing here is the wallpaper on my computer. I have no idea how to say any of these words in Spain, and we'll open up a picture for you. Uh, I I only have 15 minutes, so I have to go quickly, and I think I'll do a couple of videos because there's a lot of interesting information. And my thought was to add this poster at the beginning of each of those, mostly to be sure I want you to know that I'm glad you're here and I'm happy you're here. I think it's fun. Enjoy yourself. I do have a YouTube channel. The name of my YouTube channel is Patrick Gray. I invite you to subscribe. I think you'll enjoy it. I do have a website. This is the name of my website. And on the website is a menu, and the menu gives you a lot of different places where you can go. This is the robot hand, so you can click here to get to the robot discussions. And then that will take you to this, and you can click here to get to the robot hand. The robot hand page has what I'm talking about. I try when I add stuff, I'll add more to the top of the page. I'm going to put the Autodesk Maya files, their archive files. We know all over the world, in order for something to get an experience to happen many times before you do anything else, you have to start out by unzipping something. So I hope you're not upset that these files are compressed zip files and you have to unzip them and extract them to get them to open on your computer. This is in Maya, which is an Autodesk product. Autodesk is used, products are used for CAD to do machining, and they're used to set up 3D printing files. There's just a lot there, so I'm happy to show it to you in Maya. I do my drawings in SketchUp because SketchUp is it's easier to work with, for me anyway. A couple of other things. Obviously, don't make anything that you make that's real could hurt somebody. If you can't properly manage it, don't make it. I think a robot hand that anybody would want has to have these 4 features: size of a human hand, the strength of a human hand, dexterity of the human hand, and it won't wear out and quit working. And I asked some of my mannequins if they would give me a hand and help me with this poster, and they said sure, they would help out. What I'm really doing here is to bring out the point. I think a lot of people are going to say you have a great set of specifications for your hand, and if you try to put all of these specifications into a physically real item, it's completely impossible. And again, I asked my mannequins to give me a there you go. So they gave me a hand. They went to the robot repair area and back into the parts department and got some hands. Anyway, we'll switch. This is SketchUp here. We'll switch over to Maya at this point. I guess I should mention I did draw create the hand, the robot hand, in SketchUp. It does use hydraulic cylinders, 4 fingers and a thumb. This is 3 views of the hand as the thumb is rotating out away from the palm area. But you can see that see the boxes? This is what SketchUp does when it's getting beyond what it can draw. And I just wanted you to see that this is where the drawing was created. Now we'll take a look at it in Maya. And here I've opened that same drawing up in Maya. Maya is it's optimized. Well, I just don't know how, but Maya does not seem to be mixed up or confused by displaying these images like SketchUp is. And it's pretty. Now, the I'm not as familiar with Maya as I am in SketchUp, so everything is a little bit slower. The principle of this hand is that the hydraulic cylinders change the positioning of the fingers with respect to fine dexterity, motor activity of the hand. So the big heavy power of the hand comes from these ligaments, that this extends the finger and lifts it up, and this one pulls the finger down and curls it over. And these heavy ligaments, the forearm would be back here. This is the wrist right here. So the forearm is back here, and these heavy ligaments go to much bigger muscles back in here. And I haven't shown that. I will, but I haven't shown it. And what I'm discussing is the ability to get dexterity in the hand and move the fingers around the way that human beings can do. And you can see here the thumb is its own separate structure. And if we're looking directly on at the thumb, it's kind of tilted up under the palm, which is where it goes if you look at your own hand. And then this would be like if you're going to pick up a toothpick or a raisin or hold a pencil. Your fingers come down, the thumb goes up this way. This thumb, as you can see, is fully extended, but it can flex in. These big tendons here would roll the thumb in around these joints. And on the other hand, if you wanted to push on a door, or if you were falling down or doing push-ups, the thumb itself actually rolls up out of the way and goes over this way. And the way that the thumb does that is the thumb has in it the same set of hydraulic cylinders. Here's the two hydraulic cylinders that control the fingers, the intrinsic motions of the finger, and the thumb has that same two set of hydraulic cylinders, but it has a whole completely different set of three more hydraulic cylinders, and they can swing the thumb out laterally, so they can take it from here and move it to there, and they can move it even further this way and begin to swing it up out of the way. And these hydraulic cylinders articulate on a cardanic joint. This cardanic joint has movement in all three of its axes, and I wanted to do this with ball bearings, but that's just not going to work. And instead, what I've used is a polymer bearing, plastic polymer, self-lubricating polymer material. That's what these purple structures are right here. And they are, each of these movement areas has a pin of metal that comes out into this polymer, self-lubricating polymer plastic bushing, so that the cardanic joints running the intrinsic motions of the palm, the intrinsic motions of the hand, don't wear out. And so you can, the other thing you can see here, the human beings have the ability, this line here of the metacarpal phalangeal joints, human beings can actually move this up and down, and they can move it back and forth, and that's what this set of hydraulic cylinders allows. And you're seeing all of this in Maya. We have another Maya. Oh, now on all of these Maya files I'm going to send to my website, so you can go to my website and click on them, and it will download the zipped compressed files to your computer. And I just wanted a quick review. This is one finger in the sort of neutral position where these two hydraulic cylinders are at that condition. And if this hydraulic cylinder holds still and this hydraulic cylinder retracts its piston or its piston rod and piston head, then this whole entire finger will rotate around this joint and it flexes the finger. And conversely, if instead of this one holding still, if both of these contract or retract, then they will pull on this and rotate the finger off to the right. And if they push away from themselves, they will push on this and push the finger the other way. And the way that this is structured so that it will work is through the use of this cardanic joint concept. And this is an earlier version of the robot, or the robot hand. I just wanted you to see that cardanic joint. And I did want you to see I found a ball bearing that has the strength to be the ball bearing for this robot hand. And I put that ball bearing in a cardanic arrangement, and you can see how much bigger it is than this. And so it just wasn't going to work. I did also want to see, you can see how much bigger the ball bearing cardanic articulation is than the one that I chose using the polymer bushing bearings. And this, you can see here that this finger is just simply flexed down, and this is horizontal. But you can actually do flexion and abduction. So you can see that while this is horizontal, that's tilted out. So this finger is tilted down and also abducted. And I chose 20 degrees is what you can do without full flexion. And you can see that actually there's a place where these two structures bump into each other. And I like the 3D drawing for that. It just shows that I shouldn't have picked 20 degrees of abduction. I should have picked 15. But this is all being demonstrated to you through Autodesk. I did send the image to Keyshot. Keyshot is my three-dimensional program that I use for creating two-dimensional images. And Keyshot will let you look around. I've drawn in, this is showing the support structures. We're at 2 samples, so it's toning itself up. And I did some two-dimensional images from that. That's another advantage. This is directly imported from Autodesk, from Maya, and it shows this image. And this is a 100 megabyte PNG image of the hand. These are M1.4 bolts. And it just shows the structure. And I'll send, this is the support structure. I'll send these images to my website where you can download them if you want to, if you like images of this size. I'll put some 8 megabyte images in there just to show it, but that won't be what you're downloading. And this is 55 megabytes. It's showing the palm of the hand. And of course, she's saying, look, it's getting to be 15 minutes here. And so he replied to her, okay, fine, I'll be gone. I'll see you later. And we'll do some more of these for you, of these discussions about the hand for the robot.